Well, hello and welcome to this exercise on change in volume or rate of change. Now, I've done a similar exercise before and when I dealt with a swimming pool. Now, in this exercise, we're looking at a cylinder and it says oil is being introduced into this cylinder or this cylindrical tank on a horizontal surface. So, in effect, it's sitting flat. Okay. Now, this D here represents the depth of oil at any given time, and this R represents the radius of the tank. Okay. Now, it then says the cylinder has a diameter of 2.1 meters. Now, the oil enters the cylinder at the rate of 50 liters per minute. At time t seconds, the depth of oil is d centimeters and the volume is v liters. For part 1, it says find dv by dt, which is a ratio. Secondly, it says find the rate at which the depth of oil is increasing, giving you an answer to two significant figures. Now, one thing to note here immediately is to see that we've got various units here. The diameter is given in meters. The rate at which oil is introduced is given in liters per minute. We're given time in seconds. Okay. We're given the depth of oil in centimeters. So you need to bear all this in mind when you do your exercise there. Okay, now, so what I've done firstly is to say that 1 liter is equivalent to 1,000 centiliters cubed. Right. For the first part, the volume of the cylinder is given, or the volume of oil is given by V is equal to pi times 105 squared times D. 105 being the radius, this one here, is the radius of the cylinder. So if we differentiate V with respect to D, we have that dd over d, so dv over dd is equal to 105 squared times pi. Now, you can leave your answer at that because that would be an accurate answer there, or you can work it out if you wish. But that's fine, that answer is okay. Now that's part 1. Now for part 2, we want to find the rate at which the depth of oil changes with time. Okay. So start again with a formula V is equal to D times pi times R squared. Now D is the depth of oil at any given time. Okay. So what we need to do, we wish to find dd by dt as the rate of change of depth with time. So the rate of change of the depth of oil as time goes on. Okay. Then we want to differentiate volume and depth with respect to time. So we're looking at dv by dt and dd by dt. So if we differentiate v with respect to time, we've got dv by dt. If we differentiate v with respect to time, we get dv by dt. And if we differentiate d with respect to time, we'll have dd by dt. So now dv over dt is equal to pi r squared dd over dt. Now, this dv over dt here is the rate at which oil is being pumped into the tank. Okay? And so, if we then divide both sides by pi r squared, we have that dd over dt is equal to dv over dt times 1 over pi r squared. Okay? Right, now if we put in some figures now, we have that dd over dt is equal to 50,000, now 50,000 being the rate at which oil is being introduced into the tank in centimeters cubed per minute there. Okay, so we come up with the answer of 4.5 over pi centimeters per minute, but we're looking at time in seconds here. Okay, looking at time in seconds, so we need to divide this here by 60, and so we do dd by dt is equal to 4.5 over 60 pi, and we come up with the answer of 0.024 centimeters per second, and this answer is into SF as required. Now, I hope all that made some sense, and please subscribe. Thank you for watching, and bye bye now. Bye bye.